my gentle and of course very modern apes. My name is Erica, this is gutsickgibbon, and what we do here is I teach you about cool scientific topics that I find interesting, and I also covertly teach you by debunking pseudoscience. I'm super busy right now in real life and also with relation to this channel. I'm working on several very large projects. I'm chugging away at my dissertation, and I am fighting the existential dread of future changes that may impact me through the university and academic system in this country, the United States. But of course, in between working on my dissertation and scripting and filming and editing for major projects and videos with regard to YouTube and screaming in the woods about the state of things, I gotta feed the algorithm or this thing forgets about me. And I simply can't have that. I love attention too much. Fortunately, one of the fastest ways for me to make content is to talk about the latest discoveries in the fields that I am in or adjacent to. So that's what we're gonna do today. I'm gonna talk to you about a bunch of recent headlines that have really piqued my interest, and I'm gonna tell you why I think they're interesting and the implications that they have. Now, there are a lot of topics that I want to cover, and I do not have time to do each one of these studies justice. So I'm not going to try to do them justice. Instead, I'm going to briefly summarize them for you, and I'm going to talk about how it fits within the context of what we already know and where we can go from here. What I'm not going to do is do a several-hour deep dive into proteomics so that I can explain to you the minor quibbles that I might have with my limited understanding that I only recently acquired with the methodology on a proteomics paper, because I don't have time to do that as much as I would love to. I am easily stymied and stunlocked, I guess is the contemporary word for it, when I am faced with a big to-do list, all of the things upon which I want to do justice, I want to do well and explain them accurately. So this is a challenge for me to go through several papers and to do so in brief. But I'm going to do it because I need to, because I have to release video every couple of weeks or else the algorithm smacks me like a little stink bug that's crawling up the wall. I said that because I have one of those right now. I think they're cute though. I would never hit a stink bug. But the algorithm is not like me, and even though I am not a stink bug, I am a human woman, the algorithm will smack me for not getting regular content out to you, and I think that 10 to 14 days is about the max that it will tolerate, which is why I'm sitting here. It's not that I don't enjoy it, it's just that I would like to get other projects to you faster, and having to do regular videos does sometimes interrupt that, but usually once I'm seated, I just start rambling, and then I'm having fun again, so don't cry for me. I suppose I could do a sort of countdown, but I don't think I'm going to do that. Instead, I think I'm going to separate these papers out into general categories, and that first category is non-human apes, one of my favorite subjects. Our first paper is titled Bonobo's Point More for Ignorant Than Knowledgeable Social Partners. And this is a really important paper for a lot of reasons, right? Anytime we have a paper come out that shows additional support for theory of mind in non-human animals, I get excited. And I guess I should define what theory of mind is first. Theory of mind is, put very simply, the ability to put yourself in someone else's shoes. And there's been this debate in ethology, or the study of animal behavior, for a really long time as to whether or not non-human animals have theory of mind, or whether they're sort of just these response stimulus machines. And if that sounds dumb, it is dumb. I think that is a crazy thing to propose, and I always have. We talked a lot about theory of mind in my master's degree, which was in primate biology, behavior, and conservation, and we discussed whether or not other animals have theory of mind by looking at basically the entire literature body on the subject. And I walked away pretty convinced that we're looking at one of two things here, right? Either humans have theory of mind, and so do many other critters, just to varying degrees, some on our level or close to our level, and some pretty far off, but still a kind of theory of mind, or other animals are a sort of advanced response stimulus machine, and we are as well. We're just a super advanced response stimulus machine. There really isn't a line that you can draw that says that what humans are doing is sort of fundamentally different categorically. My favorite study on the subject concerned chimpanzees. Specifically, it concerned chimpanzees and their inherent fear of snakes. most primates are pretty scared of snakes. I like snakes, but I think if I saw one out of the corner of my eye, I would probably jump just because it's instinctual. Anyway, so they had a line of chimpanzees, walking along, and when the group encountered a plastic snake that the researchers had put out, and the chimpanzees kind of freaked out, but they would selectively warn individuals who were further down in the line, individuals that these chimpanzees knew had not seen the snake and therefore needed to be warned. They didn't waste time warning individuals who they knew had already seen it. If that's not theory of mind, I don't really know what is. But I do like seeing new papers that come to add additional support for it, and specifically show additional support for more advanced theory of mind. So that's exactly what the researchers here did, is they were testing bonobos for a more advanced version of theory of mind. And they summarized this in the abstract with a line that I sort of initially interpreted as saying that there wasn't any evidence for primate theory of mind at all, but they're talking specifically about the type of theory of mind that lets primates like humans coordinate and collaborate to accomplish a task. So the way that this study sort of functioned is they have a bonobo and they pair them with a human partner. And in order to assess how much a bonobo is aware of what information a human does or does not have access to as a partner, they hid a food reward in front of the bonobo so that the bonobo had the information as to where the food was hidden, and then they brought in a human who the bonobo was aware did not have that information. They weren't shown that information, at least not in front of the bonobo, to see if the bonobo would try to aid the human in finding the food reward, a task that bonobos at this research station are trained to know. If they aid that human, they get the reward. So they're both aware that the human doesn't have the information and incentivized to help. And the abstract sums it up quite nicely and quite succinctly, both what they did and what the results were. They said if bonobos can represent a partner's ignorance and are motivated to communicate based on this mental state attribution, they should point more frequently and more quickly to the hidden food's location when their partner is ignorant about that location than when he is knowledgeable. That makes sense. If the bonobo knows, I have seen where this food item was hidden, but my partner did not see it, then they should point at the location more frequently than when the bonobo and the human are both shown the location of the food item together, if they're capable of sort of attributing a mental state to someone else. If they can put themselves in the human's shoes and say, I saw it, but the human didn't. This makes sense. Bonobos indeed flexibly adapted the frequency and speed of their communication to their partner's mental state. These findings suggest that apes can represent and act on others' ignorance in some form, strategically and appropriately communicating to effectively coordinate with an ignorant partner and change his behavior. That's super cool. It's basically just a more advanced version of the theory of mind that we knew chimpanzees already had, right? And bonobos are a type of chimpanzee, so we can sort of group them together here. But panins do have a theory of mind, in my opinion, that has been very robustly supported, and every time we seem to test the limits of that theory of mind, it seems to just meet our expectations and indeed often surpass them. So how close is their theory of mind to ours? I think we will continue to suss it out. This second headline is a pretty quick one. There's not much to explain. It's just a cool little anecdotal observation that, they supported with data, of course, but it's an interesting little case study, I guess is how I should have presented it. It's titled Idiosyncratic Gesture Use in a Mother-Infant Dyad in Chimpanzees, Pan troglodytes schweinfurthii, in the wild. So basically, a mother-infant pair, a dyad of chimps, have a specific gesture that is only found in them, within their group, and then of course in chimpanzees at large. The infant basically tries to climb on mom's back, and they will put their little hand over their mom's right eye every single time to let them climb onto their back. And it's basically this little signal that the kid is making to the mom that seemingly no other little baby chimp uses to communicate that they want upsies. You can read the abstract of this thing if you want, and I believe there's a video in the Pop Science article that accompanied it that sort of argues or makes the case that being able to create gestures that have meaning de novo is kind of a necessary precondition for language as a whole, right? The ability to invent new words as an individual and not just, I guess, as a population, that's pretty important. So if baby chimpanzees and, their mothers are capable of inventing de novo or out of nothing gestures that mean something between the two of them, a gesture that has an agreed upon meaning that isn't just sort of signaling what it is, something like covering an eye, that suggests that the basis for inventing words is potentially a lot older, even if they are really simple symbolic gestures or words. I'll sort of say to that point, there was another pop science publication, and I can't remember off the top of my head if it had an associated scientific study, but it was warning about the extinction of specific chimpanzee gestures or cultures in groups that are threatened by human activity. Because if a gesture is only utilized by one or two individuals, and then those individuals die, well, you lose something there. You lose that gesture, you lose that culture, and you lose the ability to pass it on to other chimps, because chimps, like humans, are social learners. So when a gesture shows up in one individual, oftentimes it transmits across the group, at least for those who it is relevant to. So our third paper here is titled Stone Selection by Wild Chimpanzees Shares Patterns with Olduwan Hominins. So a little bit of background here. The types of tools that hominins use are sort of organized in a complexity scale. So the least complex, the very first most sort of primitive stone tools are called Lomequian stone tools. Those show up about 3.3 million years ago. Olduwan are the next most primitive tools. The oldest Olduwan stone tools are about 2.9 million years of age, which means they're approximately 400,000 years after the Lomequian stone tool culture. So these aren't super uber basic barely chipped rocks. These are easily identifiable stone tools that are far less controversial than the Lomequian stone tools are. And what these researchers are arguing that they found is that the chimpanzee stone selection, so when chimps are picking a stone tool to accomplish a task, they follow the similar patterns that we see when we look at the archaeological record of hominins that use Olduwan stone tools, which is really neat. And it's also cool sort of how they did this. So they identify sort of an important overlap of the Venn diagram of hominins and chimpanzees here at the beginning, which is that both hominins and chimps use a whole lot of different tool types, right? But most of the tools that chimps use are not stone, which means a lot of the tools that hominins used probably even earlier on than just the Lomequian stone tools probably weren't stone and probably did not record in the fossil record. They probably disintegrated because they were like sticks and leaves and things like that. So stone tools that chimpanzees use, comparing that to the stone tools that hominins use, that's a really nice opportunity to compare what we perceive to be a more basal condition in chimps to some of the earliest hominins, to see if that behavior sort of existed in maybe even the last common ancestor between humans and chimpanzees, which is following parsimony, because we would expect that if chimps and hominins share a specific proclivity for stone tool use, they probably inherited it from a common ancestor instead of independently evolving it. So they note here that they have documented the selectivity patterns of stone tools used by wild chimpanzees to crack nuts in Guinea through controlled experiments that induced rocks unknown to the population. Experiments incorporate specific rock types because previous studies documented hominin selection of these lithologies at the Canberra South 2 million years ago. We investigate decisions made by chimpanzees when selecting stones that vary in their mechanical properties, features not directly visible to the individual. Results indicate that the selection of anvils and hammers is linked to task-specific mechanical properties. Chimpanzees select harder stones for hammers and softer stones for anvils, indicating an understanding of specific properties for distinct functions. And this exact pattern, the authors argue here, has already been observed from Olduwan hominin archaeological sites. So that suggests that a lot of the predispositions that we have for selecting stone tools, or just specific stone tools for specific jobs, or even just the ability to select specific tools for specific jobs, is probably pretty ancient, which is neat. I don't know why, I'm not surprised by this. I don't think very many people are, but it's always good to get it sort of on the books, quantitatively speaking. Moving on from chimpanzees, we got a new hominin species, at least according to this research team, who argues in their paper Taxonomic Revision of the SK15 mandible based on bone and tooth structural organization that SK15 SK15 belongs to a brand new species of Paranthropus, one of the weirdest genera of hominin that they are calling Paranthropus capensis or capensis. I haven't heard anybody use this verbally yet, so I don't know if it's Paranthropus capensis or capensis, but either way, this was done using geometric morphometrics, which is a methodology that concerns the, surprisingly, shape of the morphology, a geometric morphometric or GM analysis of the dental arcade shape, the mandibular symphysis outline, and the M2 and M3 enamel dentin junction shape. So what they're looking at here is the actual sort of parabolic shape of the mandible. They're looking at the mandibular symphysis, so where the two sort of halves of the mandible fuse in the center, sort of where your chin is, and fused mandible is a characteristic of many, many primates, including hominins, and the M2 and M3, so that's the second and third molar enamel dentin junction shape. So that's like enamel is on the outside of the tooth, and underneath the enamel is the dentin. So it's where the enamel and the dentin meet, the junction and the shape of that junction, in order to see like how SK15 compared to a bunch of other hominins. They recognize that it's like pretty classically been classified as Paranthropus, but that it doesn't typically get more specific than that. And they wanted to see where it fell in comparison to, like I said, other hominins that are in South Africa, which we're looking at a South African specimen here with SK15. And put pretty simply, what they found is that SK15, while it does lump with Paranthropus when you analyze its shape, it specifically falls outside of the typical Paranthropus specimens, and certainly outside genus Homo. They say, although the results show that SK15 unambiguously falls outside the variation of Homo erectus / Homo ergaster, so Homo erectus sensu lato or sensu stricto, and that it is most compatible with the morphology of Paranthropus, albeit showing smaller dimensions and an absence of some dental morphological features typically found in specimens of Paranthropus aethiopicus, Paranthropus boisei, and Paranthropus robustus. In particular, SK15 differs markedly in size and morphology from mandibular remains from Paranthropus robustus from Swartkohn's member 2. Thus, we tentatively attribute SK15 to Paranthropus capensis, a more gracile species of Paranthropus than the other three currently recognized species of this genus, and discuss the implications for the existence of another species of Paranthropus in South Africa during the early Pleistocene. Basically, they're saying it's a more gracile or like lithe, limber, sort of more fine-featured Paranthropus, which is really cool, and again is pushing that limit of this question that people have had an issue with in paleoanthropology for a long time, which is how many hominins can an ecosystem support? Because for a very long time, it was sort of an anagenetic view where it was like, okay, well, Australopithecus begets Homo, and Homo begets each subsequent species of Homo until you reach Homo sapiens, each subsequent species replacing the previous one because it's just so good at competing within that environment. But more and more we seem to see that hominins can just sort of carve out their living within an ecosystem that other hominins are in. And, from my vantage point studying Miocene apes, which are sympatric or multiple species living of ape living in the same ecosystem at the same time in different niches, right? I don't see why this is maybe so surprising, because apes are, and in fact primates in general, are known for being sympatric, having a lot of different sort of members of the same group living and, again, carving out that niche without having to compete so fiercely with one another. But my hominin contemporaneity, sensibilities and sympathies clash up against my desire to stop making a new species every time a hominin falls slightly outside of the established variation. So I'm wondering if we really need to go as far as to say that this is a new species, or whether or not it's just a separate population of Paranthropus robustus that represents some previously undersampled variation. I don't know the answer to that question, but you guys know how I feel about species, so I will digress. Our next paper is sort of sticking in line with hominins now. We've moved into the hominin category, as I'm sure you've noticed. It's titled Acetabular Orientation, Pelvic Shape, and the Evolution of Hominin Bipedality. So hip shape and how hominins begin to walk upright. That's sort of what we're talking about here. Carol Ward is an author on this. She is like a pro when it comes to hominin and hominoid locomotion, so hominin specifically, but also just ape locomotion. She's kind of a leading figure when it comes to this specific subject right now. And this one's going to be a rough one for creationists who are still trying to maintain that Australopithecus was not a biped, which is something that creationists do a lot. They like to say that Australopithecus, or this sort of missing link, if you will, didn't actually walk upright, and our recreations of Australopithecus, the genus, as being bipedal when they're on the ground is basically just like hoaxery and tomfoolery. So that is not true. I hope I don't need to tell you guys this, but we are limited in how we can habitually move by the morphology that we have. A human can't spend their entire lives walking on all fours without, accruing a whole lot of pathologies. And likewise, a chimpanzee can't walk upright their entire lives without, again, accruing a lot of pathologies. So we know by looking at Australopithecus' skeleton that this thing was a biped, at least when it was on the ground. It walked on two legs. It had the same characteristics that make humans bipedal, and it also had a couple of adaptations still lingering around that would have made it okay in the trees, but it wouldn't have limited it to the trees, right? So it has longer arms, but it doesn't have an opposable big toe, for example. So this is a really nice paper. In their highlights, they say upright bipedal walking is defining feature of the human lineage. Sure, we quantified acetabular orientation in humans, extant primates, and fossil hominins. Hominin acetabular orientation was essentially human-like by 3.6 million years ago in early Australopithecus, and the shift in hominin acetabular orientation was likely driven by selection for locomotion. Surprising absolutely no one who is keeping up with this stuff, but again, we do have to do the legwork, get it, because we're talking about bipedalism, and get this stuff quantified. So there's a really nice abstract here that talks about all of it. Hominin pelvic form differs dramatically from that of other primates by having more laterally flaring iliac blades, a wider sacrum, and a larger transversely broad pelvic inlet. So basically, a human pelvis is like a chimp pelvis in a hydraulic press, where the sort of blades of the hip form a bowl shape for the pelvis as a whole that helps you anchor powerful gluteal muscles, strengthen the pelvic floor, etc., etc., etc. So they compared the pelvic anatomy, specifically looking at the acetabular orientation in humans, a ton of different anthropoid non-human primates, and fossil hominins, including Australopithecus afarensis, africanus, sediba, and Homo neanderthalensis. Did a whole lot of measurements and landmarking here, and they say humans and fossil hominins both possess significantly more ventrally, or out of the bottom, the opposite of dorsal, opening acetabula than other extant anthropoids, so other still living non-human primates, which exhibit laterally facing acetabula. The orientation of the hominin acetabulum was essentially human-like by 3.6 million years ago, well before the appearance of other unique features in the pelvis of Homo that may be associated with long-distance walking or running, thermoregulation, parturition, so birth, and larger body size in this genus. These results suggest that the ventral orientation of the acetabulum is a key component in the suite of pelvic characteristics related to habitual bipedality in hominins and should be considered in future analyses of hominin pelvic morphology. The creationists who think that Australopithecus wasn't a biped, stay losing. Rip Bozo, L+ ratio. Moving on. Thank you, Carol Ward. So both of our last two papers have to do with hominins, and specifically they have to do with Homo erectus. Homo erectus is super interesting because, in a broad sense, it is the first hominin that is considered to have left Africa roughly 2 million years ago. And I say roughly 2 million years ago because it's probably a little bit older than that, but we're not 100% sure yet, because while we have Homo erectus dated to 2 million years old, it's in Drimmelen, South Africa. And the first Homo erectus that we have outside of Africa is in Dmanisi, Georgia, at roughly 1.8 million years ago, while the oldest stone tools that we have outside of Africa are all the way in China at 2.1 million years ago. Obviously, this helps us connect some dots because it's a 1.95, so almost 2 million year old presence of hominins outside of Africa in the form of cut-marked bones. So reasonably, you could propose that hominins were leaving Africa in sort of these pulses and heading out to China and leaving these relict populations along the way. And I say relict because some of them have features that are pretty primitive and don't seem to show up in later Homo erectus. And I also say relict because we're not sure that these populations are actually Homo erectus. So I'll elaborate a little bit. Homo erectus, as I said, is known from South Africa from actual fossils around 2 million years ago. We also, around 1.8 million years ago, have Homo erectus in Dmanisi, Georgia, in the form of actual fossils. But these older stone tools, and in the case of this paper that we're looking at now, cut marks on bones, these are at least 100,000 years older than the oldest body fossils of Homo erectus outside of Africa. And in the case of the one in China, we're looking at like 200,000 years older stone tools, and they're not associated with any Homo erectus remains. The reason this is curious is because we do have another population of very interesting hominins that are found outside of Africa in the much more recent past, or at least stretching into the much more recent past, and that's Homo floresiensis. The reason Homo floresiensis, the little 3-foot-tall hobbit from Flores, is interesting to this story is because there are some who have proposed that Homo floresiensis doesn't descend from Homo erectus, but from something more like Homo habilis or even Australopithecus on the basis of its wrist morphology and on aspects of the pelvis. What this paper tells us that we're looking at now is that whichever hominin did leave Africa earlier than 2.1 million years ago, it didn't just go to China and stop there. It either left multiple times, or multiple hominins left multiple times, or it left a single time and left populations in several different locations as it made its way out there. But certainly now we can't look at it as sort of an anomaly. It seems that hominins were pretty well establishing themselves outside of Africa probably quite a bit earlier than 2.1 million years ago. Only time will tell, though, if these hominins were Homo erectus or something else entirely. And I'll show you the pictures here really quick so you can see what the cut marks look like. They're pretty unequivocally cut marks, right? These are not controversial, at least from what I know about cut marks. Maybe they were made by Homo erectus. Maybe they were made by something earlier. As I said, time will tell. And our last paper is called Homo erectus, speaking of which, adapted to steppe desert climate extremes 1 million years ago. Homo erectus, again, is this hominin that lived for 2 million years in a broad sense and was extremely technologically capable, spreads all across the sort of old world, as it were, so Europe into Asia, and makes it down into Oceania and a ton of different places, and is very, very good at carving out these livings wherever it ends up. And, the reason for this is because Homo erectus, to some degree, had mastered its ability to sort of survive and adapt in any given environment thanks to technological advancements and probably cooperation. And what this paper is arguing here is that deserts and even like steppe desert extreme types of deserts were no exception. They say questions about when early members of genus Homo adapted to extreme environments like deserts and rainforests have traditionally focused on Homo sapiens. Here we present multidisciplinary evidence from Ngaji Nyori in Tanzania's Olduvai Gorge, revealing that Homo erectus thrived in hyper-arid landscapes 1 million years ago. So again, a steppe desert, not just a desert, I guess. Using biogeochemical analyses, precise chronometric dating, paleoclimate simulations, biomodeling, fire history reconstructions, paleobotanical studies, faunal assemblages, and archaeological evidence, we reconstruct an environment dominated by semi-desert shrubland. Despite these challenges, Homo erectus repeatedly occupied fluvial landscapes, leveraging water sources and ecological focal points to mitigate risk. These findings suggest archaic humans possessed an ecological flexibility previously attributed only to later hominins. This adaptability likely facilitated the expansion of Homo erectus into arid regions of Africa and Eurasia, redefining their role as ecological generalists, thriving in some of the most challenging landscapes of the Middle Pleistocene. I don't suspect that any of these authors are particularly surprised by this, and I don't really think anybody should be. If Homo erectus, again, is this first hominin to leave Africa, it has to cross a lot of extremely hostile environments, which means it needs to be good at planning. It probably was capable to some degree of either routing in relation to water sources or maybe even carrying its water with it, and using tools like fire to stay warm as it crosses these higher altitude, colder areas as it moves up and out of its continent of origin. But still, as I've said many times over the course of looking at these papers today, it's nice to have sort of quantitative, like really well robustly researched support for that idea that I guess I've always just taken for granted. Every paper that comes out seems to fine-tune just a little bit more how non-unique, I guess, Homo sapiens is compared to our closest relatives, both living and extinct. And it also brings into finer focus the areas in which we are unique, the areas in which we are different, where we set ourselves apart, and what makes us sort of the last hominin standing and one of the last hominoids standing as well. And I think that, as science continues to move forward, please, if we have the money to do so, we will continue, of course, as I always say, to find out more and more and more. And I look forward to the next batch of papers to bring you on gutsickgibbon on this channel. If you like what I do, please consider liking, commenting, and subscribing. Even with the inconsistencies in my lighting and occasionally audio, I do really enjoy what I do, and you liking, commenting, and subscribing helps YouTube suggest my videos to people who might be interested, so it's a free way to help me sort of keep the lights on. And if you want to support me in a more financial way, you can join my Patreon. Patrons get early access to videos when I'm on top of things, which obviously I'm not at this exact moment in time, but sometimes I am, and they get their names at the end of every single video. So I would like to thank you here at the end from the bottom of my gentle and, of course, very modern heart for being a curious primate. And I'll see you real soon next time, hopefully with a longer and maybe funnier video, although I do hope you enjoyed learning with me today. See ya.